Welcome to the Fixation Fundamentals module for medical device professionals. In this course, we will discuss the different types of devices used for bone healing, discuss the concept of compression, and get an overview of basic implant techniques. First, we will give an overview of the various types of fixation available to physicians. Screws are the most common device used for internal fixation. They can be used alone or in conjunction with plates, nails, or rods. We will discuss technique later in the module. First, let's review the different types and design features of screws. Pitch is the distance between each thread, which is sometimes also referred to as the distance the screw travels before each thread engages. Next is minor diameter, also known as the inner or core diameter. This is the measurement of the screw shaft. And lastly, major diameter, sometimes referred to as the outer diameter. This is the measurement from the outer thread on one side to the other. A screw is typically referenced by its outer diameter. Cannulated screws contain a hollow shaft. A Kirschner wire or K-wire is inserted, usually with the guidance of fluoroscopy, to determine the trajectory of the screw. The screw is inserted over the wire and the K-wire is removed. Partially threaded are simply that, only threaded on a portion of the screw shaft. These types of screws are used in a lag technique. Blunt tip is a feature where screws have a rounded tip to protect soft tissues. Self-tapping screws are designed with flutes that cut the bone, eliminating the step of needing to tap. And self-drilling screws. These contain sharp tips, similar to a drill bit, that can cut into the bone, potentially eliminating the need to drill. Plates can contain different screw types dependent on the design and type of plate. For example, a compression plate requires non-locking screws. Non-locking screws can be positioned at any angle. They can be directed to avoid other hardware. And non-locking screws can be used for interfragmentary compression. Next, locking screws. These have threads on the head of the screw that engage directly with the threads of a plate. The screw is fixed at an angle predetermined by the plate design. No compression can be achieved with locking screws. And lastly, variable angle locking screws. These screws lock into the plate via another mechanism. Sometimes they are inserts or soft metal that allow the threads on the screw head to engage into the metal or other material insert. With variable angle, the surgeon can choose the angle the screw is inserted and then lock it into place. Again, no compression can be achieved with locking screws. Next, we will review compression. Interfragmentary compression is achieved by using a lag technique. This is done by inserting a screw either separate from a plate or through a plate hole. Interfragmentary compression can also be achieved by using lag by design with a partially threaded screw. And lastly, we will review fixation techniques. Compression of the fracture using a plate is usually produced by eccentric screw placement through one of the plate's compression holes. These holes are shaped like a sloped cylinder. The screw head slides down the inclined hole as it is tightened, and the head forces the plate to move along the bone, thereby compressing the fracture. It is important to use a plate that is long enough on each side of the fracture. Plate length is more important than the number of screws for ensuring stability. Let's take another look at the compression feature of plates. The compression slots have a sloped ramp, which guides the screw in the direction of desired compression as torque is applied. First, place the plate over the fracture or fusion site. The slot should be positioned over the distal fragment. Then fix the plate on the opposite side of the compression slot. Drill the screw hole in the slot farthest from the inserted screws on the opposite side of the fusion or fracture site. Insert the screw into the drilled hole. And as torque is applied, the screw will move down the ramp, proximally compressing the bone's fragments. Note the new position of the screw in the compression slot. You have now completed the Fixation Fundamentals module. It is time to take a quiz on the material we have just learned. The quiz is located below this video.